Now it's being recorded. So I apologize on the recording. We're starting on 12.6. I won't go through the whole thing again. 12.6. This is question number 3. And again, this will be posted there. But now what I want to do is I want to solve this graphically. I'm going to use Desmos. So let's go here. Let me get a new tab. Desmos.com. And what I'm going to do is put the equation in here. 8649 minus 744p plus 12p, sorry, 12, actually, let's call that x. P might work. I don't know if it does with Desmos, but I'll play with that some other time. Let's see, did I get all that right? There we go. So that's the equation we want to have graphed. Again, we don't see much, so let's zoom out. Okay, then we start to see, wow, this quadratic. But again, what we're looking for is where it's equal to 0. It's interesting, we get 2 places, so we've got 15.5 is one place, and 46.5 is the other. So there's 2 prices that give us a elasticity of demand. Let's see, let's go back. Why are we, I'm surprised we're getting 2 prices. Use them in because we're curving. Let me just make sure, has anyone spotted any errors at this point?
I just put my answer in, the
Yes.
first one of the 2, and I got it right.
Okay. It's just, I'm just, like, there's no reason why there can't be 2 answers. It probably will, both answers will give us the same revenue, is what that means, which is kind of strange. So, but again, yeah, thank you. So we'll try it. We'll do the 15.5, which seems better. If you can charge less for them and make the same amount, why would you want to charge more and make the same amount, right? So we've got, from the graph, we get P equals 15.5 is one place where this is true, and P equals, I guess we could try both of them and see if they all both work, but what was the other one? 46.5. So 15.5 and 46.5. Answer to the nearest cent. So we'll put in 15.50. And let's see if that works. It does. I'm just curious if we put in the 46.5, if that also will work. They should have said something like find the lowest value. Let's see if this works. No, it didn't like it. So yeah, it seems reasonable in a business setting, you would go for the lowest price. Anyway, but I'm just, I was prepared for one to be positive, one to be negative, and of course you always throw out the negative one. So was that helpful? Question number 3.
Yes, very much. Thank you.
Okay, thank you. So we're gonna save this. I'll change this. I didn't actually. No one in my 117 showed up. So we'll just save this. me do it on my desktop, and then I will post both the document and the video. And again, the video we picked up a little bit down the road. So there we go. And I'll sort of start a new page. So that was number 3. The other question you had was it number 5 or number 6? We're in section 12.
Number 5.
Number 5, okay.
But it's pretty similar problem.
Similar, okay.
Yeah.
Does anyone have another? So let me stop the share at this point. We come back here. Are you recording this lesson? Yes, now I am. So I see those questions. I do see, okay, so let's jump back. We've got some questions here. 12.5 on 4B. So let's jump back to 12.5. If we need to, we can come back here and look at 12.6 again. But yeah, sometimes with these, let's see, let me get out of this one. This one, let's go back to the class, 12.5. Number 4, it was 4 and specifically 4B. Let's make it a little bit smaller. Of course, to get to 4B, I have to kind of go through 4A because each question with the red numbers will be a little bit different. Let's see. So the area of, so this was related rates. Okay, now I'm getting my, so the area of a circular sunspot is growing at a rate of, see, are we still recording? Yes, we are still recording. Okay, that's good. We'll record the rest of this. The area of a circular sunspot is growing at a rate of 800 kilometers per second. Let me take a screenshot and put this in the Word document. So again, this will.
Could we use 13? Sorry.
What's that?
Could we use 1300 instead? Like instead of 800? Is that allowed?
Well, I mean, if you had that as your question, you would, sure.
Yeah. So can we use those numbers? Because.
Well, the only way I'm going to be able to check is to use these numbers because that's when I place them in. It'll say if they're red. But what you're going to do is just follow the process, and that's really the idea of this. Is that as you work through, yes, my numbers will be different than yours, but you need to be able to go back through and work with your numbers and sort of follow through. Okay. Okay.
So for that last question, you got 2 answers at 0, correct? Did you just put in the first one or the second one?
I did actually put in both. The first one, it counted as correct, and the second one, it counted as incorrect. So if you do get 2 answers, use the lower value, which would make sense. I mean, if you're running a business and you can make the same revenue charging $15 as you can make $46, you would probably want to do the $15 one. And I haven't looked at these enough, but yeah, it just doesn't make sense that you would make the same revenue charging those extra dollars. So charge the lower amount of the 2.
Okay, thank you.
Yeah. Okay, so let's look at this. So we've got a rate. So this is our rate. Remember, the area is growing. So what is area? With these ones, remember, we'll have area and we'll have a radius. With area, we've got the rate that the area is changing, which is dA dt. And the rate of the radius is going to be dr dt.
Are you on the question screen or?
Oh, Thank you.
Yeah.
Yeah, keep me, so now I have to, yeah. You guys can't see what I'm
What
talking
question are we
about.
on again? Sorry, I left to get some water.
No worries, no worries. Let's see. Now we're back. You should see the screen I'm seeing. We're on question number 4, and this is section 12.5. Okay, so we're back to related rates and question number 4. Okay. So what the question, so the area of the circular sunspot is growing at 800 kilometers per meter. So that's giving us the rate of the area. So dA dt we know is 800. And notice we're going to be able to somehow figure out the rest of all this stuff given enough of the other information. So for the A part, how fast is the radius growing at the instant when it equals 700 kilometers? So what they're telling us is that the radius is 700 kilometers. And then we're going to be able to find out what they're asking. The question's asking what's dr dt, what's the rate? Okay, so for this one, we have to know that the area is equal to pi r squared. We've got dA dt, and in this question, they're giving us the r. We know this is still 800. We're looking for dr dt, and what we're missing is A, but what we're going to have to do is plug the 7,000 in here to calculate the A, and then what we're going to be able to do is calculate dr dt by finding the implicit derivative of the area function, right? So the implicit derivative, I guess let's start there, taking the derivative of this relationship, the derivative of A is dA dt, so that's the derivative of A with respect to t, and again, it's really, the derivative of A itself is just 1. Over here, pi is a constant, so it stays pi. The derivative of r squared is 2r dr dt. Okay, actually we don't need to calculate A here because what we're solving, the question wants to know what is, the question is what is dr dt? So we can get that because we know dA dt, that's 800. We're given R is 7,000. And here's dr dt. So we just go ahead and do all the multiplying. They want, let's see, they want 3 decimal places, so we're going to use pi here. So we got 800. 2 times 7,000 is 14,000 pi dr dt. Let's divide both sides by 14,000 pi. And we get that dr dt is 800 . Oops. 800 divided by, I'll put a parentheses, 14,000 pi. So Let me try that again. I don't think it worked right. 800. Times pi. Close the parentheses, hit enter, and that's 0.018 to 3 decimal places, right? 0.018. So the radius is changing by 0.018 is what we came up with. Let's check that before we go on to the next one, I guess. Okay, that's correct. Again, a small number, it's kind of like, I'm not always sure. I don't really have a good feeling for what these values are going to be, but the radius is changing by just a little bit to make that change. So that's the A question. Put that there. The B question, how fast is the radius growing at the instant when the sunspot has an area of 490,000 square kilometers? So in this one, we do need to, let me change to green here, since we have this space here. Okay, so what we're going to use is use the area formula to find the radius first. So 490,000 is equal to pi r squared. And then once we've got the r, it'll be just like, it'll follow through here. Divide both sides by pi. So r squared equals 490 divided by pi. You could, I guess, leave it in there at that, but so it's 155,974. I'm going to go out 4 decimal places. I'm going to put it over on my other screen so I can see it while I write. So we came up with 155,000.
It was 971, not 974.
Yeah, that's what I got as well.
971, yeah. 0.8442.
Yep.
Is that correct? 155,971.8442.
Yes.
Okay, good. Yeah, sometimes yeah, there it is right there. Okay, so that's r squared. We've got to take the square root of both sides. It'll give us a plus or minus answer, right? Because there's a negative square root, but we'll just use the positive side. So now, let's see, where are we? There we are. So let's take the square root of this. Where's my square root key? Well, let's raise it to the 1/2 power. I don't see a square root key on here. So we'll raise it to the 0.5 power, which is the same thing as a square root. And we should get 394.9327. 394.9327. 9327. Did I get that part right?
Yep.
Thank you. Okay. So again, now this is just going to be like we did over here. We're going to use this formula for the implicit derivative of the area formula. So let me just rewrite that. We're going to have dA dt equals 2r pi times dr dt. And all that's changed is the ADT is the same. That's a constant. That's the 800 kilometers per second. And then the R this time is 394. So it's less than what we had. So we should even see a smaller, I would assume, a smaller rate of change. 394.9327 times pi dr dt. And so we're going to take 800 divided by this whole part here, right? So we just divide 800 I think this will just be better to put it all in the calculator at one time. That will give us dr dt. And so let's clear this out. We're going to take 800 divided by, I'm going to put a parentheses just to make sure order of operations all works out, 2 times 394.9327 times pi, close the parentheses, it equals, interesting, it's actually, it's growing faster. That makes sense, yeah. If your radius is smaller and the area is changing at the same amount in the beginning, your radius actually has to change more to get that 800 extra square footage. As it's bigger, a smaller change gives it to you. So again, my intuition was going wrong. It wants 4 decimal places, so 0.3224, and hopefully with all these decimal place stuff, we're accurate enough. 0.3224. Okay, did I get that part right? I think so. Let's plug it into the actual answer over here. And let's see if that works. So we're kind of in the ballpark area, and let's see. Okay, it liked it. Was that helpful for who asked that question?
Yes.
Okay, good. So again, I will post both this document so you could just pull it up and look at it. Some people that might be better. There will also be the video working through it. That takes a little bit of time because it's the way Zoom does. It has to convert it to something, and then, but I'll have it uploaded by this afternoon, so that again everyone can take the benefits, and hopefully we'll just keep moving forward. And my goal right now is just get through the homework, get 100%, practice it. Remember the review for the test is available, so you can start reviewing that. Would you guys find it helpful if I went ahead and posted the answer key to the test review?
Yeah, so we could compare our answers. That'd be wonderful.
Okay, let me do that. I'll, as soon as we finish here, I'll post in Canvas the answer key for the practice test for 2. So then, yes, you can start practicing and I think you'll see from last time, the practice test and the actual test were very, very close to each other as far as content-wise. So if you're able to work through the complete practice test, you should do very well on this second test whenever we're going to have it.
Excuse me, Professor, are we going to go through practice exam together, or it's kind of, yep?
Yes, we will. Yes, we will do that as well. In fact, what I will do is we'll do it two ways. I will work through it on a video offline, and then I'll work through each of the questions in a separate video. And I'm thinking to make it easier, I'll actually do a separate video for, at least for each section. So then the ones you're struggling with, you can look those up. We will also, like this during class time, we will have a full, at least one class period, maybe two, where we can work through the test together as well.
Okay, this is super helpful. Thank you.
Sure. You're welcome. You're welcome. Yeah, so just, don't be afraid to ask for anything. And I'm open. I don't feel offended about anything. And, because I'm learning as much as you guys are, and I just want to make this as powerful as being in person and maybe more. So
Could we do 8 and 9 next?
8 and 9, this
Preferably 9.
preferably 9. Okay, let's go
Well,
to 9.
both would be preferable.
Okay,
Yeah.
let's take a look here. We did 8 in class. Or I think we did 8 last time, didn't we? So there should be a video on it. Let's do 9, and let's see, what time is it? Well, we can go over a little bit. So let's do 9 together, and then what I'm going to do is 8 is the video from what's today? Wednesday. I don't know about you guys, but I'm even losing track of days. I forgot to put the trash out last night, and it was supposed to be pickup time. I don't even know what day of the week it is anymore.
Yeah, well, same here. My state's on mandatory quarantine, so.
Oh, you are? Okay. So, yeah.
I'm staying inside for.
We just are not leaving the house. We fortunately have enough food for at least another week or two, and we'll be fine. We'll do well. Okay. Let's see. Where do we want to? So number 8. Let's look at number 9. Let's look at number 9. So I want to do a snap. Let me pull that up first. So I've got to get this.
Thank you for doing this, by the way, because a lot of my other teachers are just saying good luck.
Oh, no.
It kind of sucks, but it's good to have a teacher that actually helps us with the homework and stuff that's not taught in class,
Well,
Thank you. Yeah, I second that. Thanks.
I totally agree.
I remember I almost dropped out of
Yeah,
school
and you're
because
different
of math.
scenery,
So,
really.
thank you. And this is, I don't know about you, but this is kind of my life. I don't do much else. I don't have many hobbies. It's just teaching and doing the best I can at teaching. So let's see, what do I want to do next? I want to insert a page break. So we'll start this on a new page. And okay, so let's do this. And this is 12.5. So this also is related rates. I think I may have done this. There might be a similar one in the discussion forums. I think someone posted this as a question, and I may have worked. I remember working through one of these. So, but we will definitely go through it, and but there might be another one someplace else as well. So if you want to see another example, okay. So yeah, this took I think about 10 minutes to work through. We're given this function here. This is the quantity function. So this will give us a quantity. X is the mean household income. So X is the amount of income that a household's making, and the median income for a community. So they're making 25,000, which is in this is in the domain. We're told that when at that income, the income itself is increasing at 1,500 per year. How many computers per household were there? So let's see, what are we doing? Okay, so first, how many computers per household were there? Well, we're given X. X is the mean household income. X equals 25,000. So to find this part, we just plug that in for X. So for what we're going to call the A part, you simply take the formula and I write natural log as a script because it's really a function. So all we're going to do is we're going to plug the 25,000 right in here for X. So it's just going to be a simple calculation. Of course, nothing is simple, right? 25 minus. Okay, so we're just going to plug this whole thing into the calculator. It'll give us a number. Okay. Move it over a little bit, clear it out. So 0.3456 natural log. There it is down here. Oops, it works differently. So actually, let's do it this way. 0.3456 times 25,000 natural log. So notice how it's taking the natural log of 25,000. And then we're going to subtract 3.042. And it'll do it all in one step. We get 0.4577, and they want it to 4 decimal places. Actually, it's going to be 0.4578. We round it out. Okay, what does that mean? That each household has about half of a computer. I don't know how that works, but so it takes about 2 households, a little more than 2 households to have a computer. So out of 100 households, you'd have about 45 or 46 computers is what that's saying at that income level. So let's check it, 0.4578. And the reason I also check is because I know this WebAssign can be very tricky about rounding and being off by a decimal, but we're okay. So we used enough decimal places and everything, so that's correct. How fast was the number of computers in a home increasing? Now that's probably the reason why you asked. That's the harder part of the question, but that's where the calculus comes in. What we're going to do is we're going to take it's a related rate. How fast is the number of computers in a home increasing? We know the rate at which the income's increasing, so that's going to be a related rate. What we're going to do is, for the B part, let me scroll up a little bit. For the B part, we are going to take the implicit derivative here. So let me just write that down. Q equals 0.3456 natural log of X minus 3.042. We're going to take the derivative of everything. Is that right? Yes. So the derivative, related rates, this is it. So the derivative of Q is dq and And this is all changing per year over time. Yes, apologize for my thinking, but dq dt, because it's changing over time, right? Computers just don't magically change, it change over time. When we take the derivative of this part, remember that, okay, this 0.3456 is just a constant multiplier, so that stays at 3456. Derivative of natural log is 1 over x. It just is. So if you take the natural log of x and you take its derivative, it's equal to 1 over x. So that's one we just have to sort of memorize. And then since we took the derivative of x, we're taking the derivative of x.
Hey, Mr. Little Crow.
Yes, sir.
It's supposed to be a 6. You spelled it wrong.
You see, I transposed it, didn't I?
Yeah.
So those of you who are thinking I'm not dyslexic, you now know, you have the proof. Yes, thank you. Thank you so much. These are the kinds of, let's see, small eraser. Give me the small eraser, come on. That's, yeah, see that, I need your help too, so. 5, 6. Okay, and then the derivative of negative 302, this is just 0, right? So that's why it drops off. So now, okay, yeah, that's looking better. Now we come back, we're still using all the information they gave us. Our income is 25,000, so that's going to go in for X. The rate at which the income's increasing is 15,000 or 1,500. That's going to go in here for dx dt. Okay, and then this is just going to be, that's what we're looking for. We're looking for how fast was the number of computers in the home train. We're looking for dq dt. Okay, so dq dt 0.3456, and I'm going to just divide by the 25,000, that's the x, right, divided by x, and the x dt, so that's times 1,500. Okay, so I do the math on this, and that's going to be our answer. So 0.3456 divided by 25,000. We'll just hit the equals button. So that's that. And then we multiply times 1,500. So 0.02. So every year we get 0.02 more computers in our community. Again, thinking in terms of larger, so for every 100 families, 2 more families get a computer, right? It's kind of a small thing going on, and they want it to 4 decimal places. So actually 0.0207, 0.0207, 4 decimal places. And let's just check that one. And that's about in the ballpark of the last one. Again, it might be off by a few decimal places or something. Nope, it's good. Okay, did that one make sense?
Yep.
Okay, okay. So do you want to take a look at 8 still?
Sure, might as well as we're here.
Well, we're here, yeah. If you guys don't have any place to go, I'm not going anywhere. So.
I got it.
And again, if you need to leave, you can leave. I'm not looking to try to make anyone attend or do anything. I just, just learn the material however best you can, and we can spend more time here. That's fine. Let's see, I need this. I want to take a screenshot. So I want this new one. I'm going to take this and paste it in there. I feel like I'm growing. This is pushing me to do things I always thought of doing, and things that I'm not real comfortable with either, but I'm just having to get comfortable with them, and then I think it'll make us all stronger and better in the end. That's my hope. Okay, so for number 8, this again still in 12.5. I'll put that there. And so the point on the graph, y equals 1 over x, is moving along a curve in such a way that its x-coordinate is increasing at a rate of, so the x-coordinate is increasing at 2 units per second. What is happening? What is happening to the y-coordinate? Okay. So again, what we do is we start with the equation we're given, and actually instead of 1 over x, let me go ahead and rewrite this as x to the minus 1. So we'll take the derivative of both sides. Derivative of y is 1 dy dt. The derivative of x to the negative 1, the negative 1 comes down. X, subtract 1 from it, becomes to the minus 2, and that's the derivative of x with respect to t, dx dt. Okay. X coordinate is increasing at a rate of 2 units per second, so this is dx dt, the rate of x. Y coordinate at the instant that the y coordinate equals 3, so we know what y equals. Y equals 3. And what that's going to be is to find out the rate of the y coordinate. We don't really need to know y, we need to know x, but by putting it into this, we can find x, okay? So what we know is that 3 is equal to x to the minus 1. So I'm going to rewrite this as 3 equals 1 over x. Multiply both sides by x, so 3x equals 1. Then divide by 3, x is equal to 1/3. Okay, so that's what we need for here. So we now have x to plug in. We've got our dx dt. So we get dy dt is equal to 1/3 to the negative 2. The x dt is 2 times 2. Oh, and don't forget about this negative 1 in front. So there's a negative. So it looks like we're going to be decreasing.
Where did you get that multiplied by 2?
Good question. Let's see.
Fifth unit.
Oh, I gotcha. There you go.
Okay, yeah, so it was sort of given when they give us the rate, that's the rate there. Does that make sense? Okay,
yep.
So when we're taking 1/3 to the negative 2, a negative exponent does a reciprocal. So let's come over here. So that is 3 to the positive 2, right? The negative exponent does a reciprocal. 3 squared is equal to 9. And so this part here becomes negative 9 times 2. That's what dy dt is. So dy dt is negative 18. So our answer is going to be decreasing, because it's negative, at a rate of 18 units per second. We don't put negative 18 here because we say it's decreasing. We just put the 18. Okay, so we come back to it. Let's just go ahead and put it in. So we select here, it is decreasing at 18 units per second. Let's check it out. And that's correct. Okay. So I've got to take a little break here. Again, go ahead and submit any questions you have through Canvas. I'm also doing those as videos if I can get to them. Travis is also monitoring those so we can get you answers fairly quickly there. Let's see, here we are back here. Anyway, we'll keep working through the weekend. I'm still here, I'm home, so do send those questions. So we got 8 and 9. Okay, there we go. Let's make sure. I think we got all the questions answered today. So you guys stay safe, stay isolated, but keep a good sense of humor, and let's just keep making it all happen. Okay, thank you guys for
Thank you,
showing up.
Professor. Thank you so much.
Thank you.
Thank you. Have a good one. Stay safe.
Bye-bye.
All right, you too. Take care. Bye-bye.